Welcome to Unit 4, Lesson 8, Video Notes about Compound Interest. So we're just going to be we're kind of deriving the compound interest formula right now. So we have, for an investment with the following parameters, write a formula for the amount the investment is worth, A, after T years. So we have P equals the amount initially invested, so that's your principal. Your R is your nominal yearly rate, which is the percent in decimal form. And then your N is the number of compounds per year. So what we're just looking at right now, our formula, we have A of T times our principal so P times 1 plus our rate as a decimal divided by the number of times it compounds per year, all to the N times T power. So you need to make sure you write this in there because we will be using this. All right, so it says the rate in the previous exercise was referred as the nominal in-name only rate. It is known as this because you effectively earn more than this rate if the compounding period is more than just once a year. So because of this, bankers referred to the effective rate, the rate you would receive if compounded just once per year. So anytime we're looking at things, we're going to be looking at the effective rate. An investment of a nominal yearly rate of 5% is compounded at different frequencies. Give the effective yearly rate accurate to 2 decimal places for each of the following compound frequencies. Show your calculations. So basically what this is saying is quarterly means you're going to compound every quarter, and there's 4 quarters in a year. So you're going to compound every quarter, so 4 times a year. So when we're looking at this, we're not looking at the amount of money or anything, so we don't need the principal. We're just trying to look at the different type of percentage of interest that you'll be receiving. So first thing I'm going to do is I'm just looking at the inside part of the formula, the A to the A of T equals P. We're not looking at that, we're just looking at the other. So we're going to look here, we have 1 plus, my rate is 5%, I have to make that as a decimal, so it's going to be 0.05 over 4, all to the 4th power, because it's only 1 year, so it just goes to the 4th power. So this is for every quarter, this is what it would work. So then we're going to look here, and we're going to get into the calculator. And we're going to put it in the calculator. So let me get to my calculator. And I'm going to put parentheses 1 plus 0.05 divided by 4 in parentheses to the 4th power. And that's going to give me 1.05 0.95. So we're going to look at this. We're going to write that on here. So we said 1.05095, and it would continue. So what this is just saying that is you would multiply your principal by this every year to get your total amount that you've earned. For the effective investment rate, you just take this and you're ignoring the 1 and you're going to bring this over by 2. You're making a percent. So it's going to be 5.09% would be your total. So then we're going to look at monthly. Well, typically you think, okay, we're compounding it quarterly by 4. We're going to do monthly. Well, that would be by 12. So you would think that you would get more money. Well, let's check it out. So I have 1 plus 0.05, because we're still using that 5%, divided by 12, all to the 12th power. When I put that out into the calculator, I get approximately 1.05116. So when I'm going to do this and I'm going to make it into a percent, it's going to go out to 5.12%. So it's really not that big of a difference from the 5.09% to the 5.12%. It's 0.03% difference. So now we think, okay, daily, that's going to be a huge difference, right? Because we're compounding that 365 times a year. So again, I'm going to have the 1 plus 0.05 divided by 12. Oop, it's not divided by 12, though. It's divided by 365 to the 365 power. When I do that in my calculator, I get 1.05126, etc. So I put that as a decimal as 5.13%. So if you look at this, compounded quarterly is only 0.04% difference than compounded daily. However, if I'm investing $1 million in my bank account, that does end up being quite a bit of money. Right, so now we did compounded specific times. So now we're going to do compounding continuously. So it's just going on forever and ever. Every moment it's being compounded. So the continuous compound interest formula. So for an initial principal P compounded continuously at a nominal yearly rate of R, the investment would be worth an amount A given by A of T equals P e to the R T. So remember, we just got done using the E and the natural log, so this is nothing new. This is, just so you're aware, is known as the PERT formula. So looking here at exercise 5, yes, I know we skipped some. This says a person invests $350 in a bank account that promises a nominal yearly rate of 2% continuously compounded. Write an equation for the amount this investment would be worth after T years. So we don't know the T, but we know the other concepts of it, or the other parts of it. So looking at it, I have my my P is the 350. My R is 2%, so as a decimal be 0.2. Or 0.02, excuse me, and then our T is, we don't know that yet, so it's just going to be stay at T. So when I'm going to put this into the formula that was given, you have A to the T power equals, my principal is 350, B to the 0.02 T power. Let me write that a little bit better. 0.02 T. So then when we go to the next, to B, it says how much would the investment be worth after 20 years? So the investment after 20 years, well, what am I going to put 20 in for? T. T is the number of years. So I'm just going to put A of T equals 350 E 0.02 times 20 power. Now we need to put that in the calculator. So let me get the calculator. Here we go. And so I have 350 to the E. So it's just E to the X that automatically goes up like this. And we have 0.02 times 20. And when we get that, we get 522.139, which we can round up to 522.14. So I would have $522.14. Then it says algebraically determine the time you will take for the investment to reach $400. Round to the nearest tenth of a year. Okay, so this is where we're going to be putting our skills in from last lesson. So I have $400. That's what I'm wanting to get. Equals my principal, which was given to us up here, is 350. So it's 350. My starting, it says principal, but it's your initial value. E to the 0.02, but we don't know the t. Okay. Well, we need to solve this. This is just like our last lesson. The first thing we need to look at is we're going to go ahead and draw that wall. And we need to get E all by itself. So I'm going to divide both of these by 350. That cancels out. I'm just going to leave the 400 over 350. I'm not going to put that in the calculator yet. You're not going to get a whole number, so we're just going to leave it like that. And then we have E to the 0.02t. I need to get rid of that E. So remember, I can put in the natural log to both. And that's going to cancel that out. So at this point, I'm going to have natural log of 400 divided by 350 equals 0.02t. I want t by itself, so I have to divide both of those. So I'm going to, you can pause the screen if you need more time to write it. I'm going to go to my calculator. So I'm going to have the natural log is control e to the x power. There we go. I'm going to have 400 divided by 350. There's not one to work. There we go. Then I'm going to get to the other side of the parentheses and say divided by 0.02. And that gives me 6.67657. So 6.67 years. I believe it said up here round to the nearest tenth of a year. So we're going to go here, and this will round up. So it is 6.7 years in order to get our investment up to $400. Now it says, what is the effective annual rate for the investment round to the nearest hundredth of a percent? So the same thing is going to be done. We have so we've been using the nominal interest. Now we're looking for the effective annual rate. So first off, we're going to just look at it. And I have, if I set it at 350 e to the 0.02t power. Well, I can use my properties of exponents and bring this out to 350 e to the 0.02 to the t power, because that's being multiplied. Well, then I can go to my calculator and I can evaluate this. First off, I need to know that this here is what's being done yearly. So this is what's being multiplied every year. Okay, so yearly multiplied. I'm going to go to my calculator and I'm going to put e to the 0.02 power, and I get 1.0202. So I'm going to get 1.0202, and that's e 0.02 power. Well, then I'm just looking, remember, I'm just looking at this part, and I'm going to bring it, so my effective rate is going to be 0.02%, because you have to turn that decimal into a percent. So you multiply by 100. Make sure you write down all your questions you have and bring them to class tomorrow so that we can answer anything you have.